Okay, stoichiometry is using the law of conservation of mass and a complete balance formula equation. Actually, this is a complete balance formula equation, but more specifically, it's a stoichiometric equation. And stoichiometry is using constant ratios that are inherent within this chemical reaction representation to predict quantities. I won't say mass because it's more than mass, okay? Now, it all comes down to moles. If I have 1 mole of this, I need 3 moles of this and 2 moles of this. Do you understand that? The ratio of hydrogen to nitrogen the mole ratio is 3 to 1, hydrogen to nitrogen. The mole ratio of ammonia to nitrogen is 2 to 1. No matter what number of moles you have, if you have 1,000 moles, it's still, the ratios are the same. They don't change. They are constant. Now, what is the molar mass of each one of these particles from the equation? Can you guys participate? Get out your calculators, and because otherwise I won't get through this. Okay? So, what's this? You don't really need a calculator for this. Go on, hustle. Yes. 28, good. 28, 2, and what's this?
17.
17, excellent. Now, you want to speak up so the people, they don't think that I'm answering these questions myself. Okay, you with me? Excellent. Now, excellent. I like that. Now, here I have 98 liters. 98 liters. Yes?
Yes.
Now, this is what's key. Everything has to revert back to moles. So let's get the moles done. I'm just giving you a hint. If you have moles, you can get anything you want. Okay? So let's do the mole thing. How many moles are represented by 98 liters? Now, how many liters are in 1 mole of any gas? We're assuming, if they don't tell you, obviously we haven't done gas laws yet, but we've done stoichiometry, and at STP conditions, you need to know what STP conditions are. What are they? 22.4 liters of gas, but what are STP conditions? 0 degrees Celsius and 1 atmosphere. Understood? Okay, now. So it's 22.4, right? 1 mole. So if I have, if 22.4 liters are 1 mole, Neve, right? How many would 98 be? How would you do that? Well, if you have a volume need, you need to just hold your horses. If you have a volume need, 98, right? And I need to know how many moles that is, right? Just think logically, right? Zone in here, okay? You're going to learn this right now. You ready? You would need a representation of moles in terms of liters, right? Right? So doesn't 22.4 represent 1 mole in liters? Of course it does, right? So if I said to you, I had 22.4 liters, how many moles would you have? 1, right?
1.
Right? Okay. If I said I had 44.8 liters, how many moles would I get? I'd have 2. How did you do that? Didn't you divide the number of liters by 22.4, right? So how many 22.4s go into 98? Use your calculator, Neve. Give her a shot. Give her a chance. What do you got? Round it to 10th place, otherwise we'll go out of our minds. What is it? 4 point what? 10th place.
4.4.
4.4. Is that good? You get it? That's all. Is that hard? That you've just cracked the entire problem. That is the Rosetta Stone of this problem. You're on your way. Okay? 4.4, right? Yes? Well, what is it? You tell me. What is 98 divided by 22.4? What is it exactly? Give me 3 semi figures. What is it?
It's 4.375.
4.375 would be 4.4. She's right. Well done, Dee. All right, now, let's do these. That should be easy, right? If I'm doing nitrogen and I have hydrogen, what is the constant mole ratio of hydrogen to nitrogen? It's right in the problem. What is it? Look at it. It's staring you right in the face. You got to think. You don't know what a coefficient means? Go ahead, Will.
1 to 3.
I said hydrogen to nitrogen.
3 to 1.
3 to 1, right? 3 to 1. Use the problem, guys. You're struggling. Let this do the problem for you. Be a spectator. Let this work itself out. Use your tools. Yes? So let's put down the constant ratios. So it's going to be 3 hydrogen to 1 nitrogen, which is 3 to 1, obviously, correct?
Sir.
Yes, honey.
Yes.
Okay. And then that's going to equal hydrogen 4.4 to X, right? Let's see if that's coming out. Okay, good, perfect. Okay, 4.4 over X. Solve for 4.4. What do you get? X equals what?
13.2.
13.2. You get it? 13.2. Yes or no?
Yes, sir.
No.
I don't.
Is that right?
No.
How is that right? How is it 13.2? Well, how did you get that, Will?
I took 4.4 and multiplied it by 3.
Why would you do that? Yeah, do you know how to... We're having a mathematical meltdown. Just give us a moment to talk. Cross, multiply, and divide. Just technique.
Right.
Okay? You wear glasses normally?
1.50.
Well, why don't you put them on?
1.50. Or 1.46. Divided by.
So 1 times 4.4 divided by 3, right?
Yeah.
In other words, what times 3 is going to be 4.4? Something between 1 and 2, right? Isn't it? Right? If you do it 13, is 3 times 13 4.4?
No.
3 times 13 is 39. So I looked at that and I said, As well as I like to usually work with a verification. Okay. So what's the answer? Give it to me in tenths place. 1.5.
Yeah.
Okay, good. All right. And what's this one? Can we just add them together?
Yes.
We can?
6.9.
So moles are conserved, is that right? Let me just remind you of the conservation law. You ready? Just work it out in the title. Are you ready? The law of the conservation of mass. Does it say the law of conservation of moles? No. It's the law of conservation of mass. Okay? So what's this mole going to be? So this is going to be, you're going to compare this with this now, right? So it's going to be 3H2 over 2 NH3, 3 over 2 equals 4.4 over X. Is that right? Did I do that correctly?
Yes.
Okay. So what is, Will, would you like a shot at redemption? That sounds like the title of a book, doesn't it? Like a sports book. A shot at redemption. Or the shot at redemption. Okay. Yes, what do we got? Okay.
Figure it out.
Okay.
Can you read them out?
Dr. Miner, your son is squinting. I just want you to know that.
Redemption is a song.
Okay. Is it really? A shot at redemption is a song?
Yes.
Okay, so Will,
Yes.
would you like me to help you see?
Yes, please.
Excellent. 2 times 4.4 divided by 3.
4 divided by 3. Alright. It says on my calculator, after I typed in exactly what you told me, 2.93333.
All right, and I said the 10th place.
Alright. So that would be 3.
And you're suing your hearing doesn't work like your eyesight. Very good. Excellent.
2.9.
Is that right?
Yes.
What is it?
2.9.
2.9. 2.9. So that's going to be 2.9. Okay? Professor Minor, I'd like to see you after class. Okay. All right, now. So, if 1 mole is 17 grams, what would 2.9 moles be?
1.
We already cracked this. This is cracked, right? Easy,
Yes.
right?
Yes.
So isn't this the molar mass? What is the molar mass, Ella? The molar mass is the blank. Remember I said if you can do this, you're good, you're cooking. But I said you also have to outline, so you have to know terms,
Yes.
right? So what does molar mass mean? Define for me molar mass. Open your book if you have to. Go online and give me a definition of molar mass. And trust me when I tell you, it's very simple. Fishman.
Mass of a given substance divided by its amount of substance.
Too complicated. Yes?
That's a physical property.
Physical property. The molar mass. The molar mass. Look at it. Look what it says. Grams per mole. So tell me what it is.
The mass of a given substance.
But the unit labels are grams per mole. Yes?
It's the amount of grams in substance in mole.
Yeah. So well put. Is that like a South African thing? Excellent. God bless South Africa. Excellent. We didn't always say that, by the way.
I know.
But now we can. Okay. So it's going to be the mass per mole, right? So this is the mass in 1 mole. So if 1 mole is 17 grams, what's the mass of 2.9 moles?
49.3.
What'd you say?
49.3.
49.3? Is that what you said?
Yes.
Is that correct? Do we have a verification?
Yep.
49.3?
Yep.
Is that correct? Excellent. What's 1.5 times 28? Wait a second, I can do this. So 14 plus 28, 42?
Yep.
Is that right? Mental math, 42,
Yeah.
right? And then what is,
Mr. Darcy, freeze.
I'm putting it in the wrong column. Sorry, guys.
That's
Sorry. Yes, I know what Will is saying. Mr. Darcy, you're standing right next to the board with glasses and you can't see. Okay. All right, so this is going to be 42. This is going to be what?
49.3.
Which one?
49.
Which one is 49.3?
Last
Last
one.
one.
This one?
Yeah.
Yes.
49.3. And then this one is going to be 8.8.
Yes.
Okay, so can we just say 9? Is that all right? Is that okay? 8.8. 2 times 4.4. Okay. So if I have 22.4 liters per mole, and I know the number of moles, can you tell me the total volume? Well, tell me. I have 1.5 moles. Shema. Blah. What do I got?
33.6.
What is it?
33.6.
23.6?
33.
33.6. Excellent. 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 What's this one?
1,000.
64.96.
Is that correct?
Yes.
So can we just say 65? He said 64.96, and I'm just rounding it. Is that okay? Where, we really don't care about the answer. I mean, we want it right, of course, but it's the process. So if you round things, don't give me a lot of significant figures. Remember, you hear that knock on the door at 2 o'clock in the morning? It's the significant figure police. SFP. It's right on their jackets. They carry badge and nightstick and terrible. Okay? So, now, I'll tell you why this problem is really cool. A, you can redo this chart blank and try to do it again. Or, what you can do is you can erase them all. I erased them all, but I need one in there. I didn't like the one that when I remembered. What is this? What's that value? 4.5? 1.5, 1.5. And then fill the chart in. There's one thing I didn't do. I'm kind of rushing through this. I've got 30 seconds, so let me do it right now. What you should do, the first thing you should do is finish this, right? So this is 28, 6, 34, 28 and 6 is 34. I love to do that. It's just an easy reference. Yes? It's an easy reference. You get it? Yes? So, I have 3 videos on the board, I'm going to have 3 videos online. 3 of these problems. Where each problem represents actually 9 problems. So there's 27 individual small problems that you can practice. So I'm going to tell you something. I'm going to give you a probability. If you can do this chart and you do a really good outline, not an outline like some of you have done, you know who you are, you'll do well. 100. You will. This next test is much shorter because there's calculations involved. So it's a shorter test. But I think to date it should be the most difficult test. However, if you know how to do this, and I'm not suggesting it's easy, I'm suggesting it's more straightforward than you thought before today, because we did a lot of this in piecemeal. Now I'm kind of putting it together. Yes?
Yes.
Have a great lunch.
Look.